What if the planet we call home was not always the size we know it to be today? This question forms the basis of the expanding Earth hypothesis, a fascinating concept that was first proposed by Roberto Mantovani in the late 19th century. Imagine, if you will, a world not divided by oceans and continents as we know them today, but instead a single vast landmass that blankets the entire surface of a smaller Earth. This was the world as Mantovani saw it. But our planet, as unyielding as it may seem, is far from static. Under the immense heat and pressure of our planet's interior, thermal expansion occurs. This process, coupled with volcanic activity, causes the Earth to gradually expand. As it does so, this unified landmass begins to fracture, breaking apart into the continents we are familiar with today. This vision of an expanding Earth was not just a flight of fancy. Mantovani's hypothesis was grounded in scientific observation and analysis. It was an attempt to explain the puzzle of continental drift, without the continents actually drifting. Enter Klaus Vogel, a German engineer with a keen interest in this hypothesis. Vogel took this concept and made it tangible. His globes, designed to fit the continents onto an Earth that was 20% smaller, provided a compelling visual argument for the expanding Earth hypothesis. They showed how neatly our continents could fit together, like pieces of a grand geological jigsaw puzzle on a smaller Earth. The expanding Earth hypothesis, however, didn't stop with Vogel. The theory continued to evolve and inspire, capturing the imagination of other thinkers. One of these was Samuel Warren Carey, who developed his own model of an expanding Earth, independently of his predecessors. But the conversation didn't end there, as the theory evolved further with the work of Samuel Warren Carey. This marks the beginning of a new chapter in the story of the expanding Earth hypothesis, a journey that takes us from the past, through the present, and into the future of our ever-changing planet. Samuel Warren Carey, an Australian geologist, took this concept and ran with it. Carey created his own model of an expanding Earth, a theory he developed independently, unaware of the work of others in the field. It wasn't until 1956 that Carey learned of the work of Otto Hilgenberg, a German geographer who had also proposed a similar theory. Yet Carey's contributions to the hypothesis were significant. Carey's work led him to explore the idea that thermal expansion, driven by the Earth's molten core, could cause the planet to gradually increase in size. This, in turn, could explain the movement of continents over geological time. But let's take a leap forward in time to the Uniplanetary evolution theory. This theory suggests a fascinating idea that every planet in our solar system represents Earth at different stages of its evolution. From the fiery, iron-rich beginnings of Mercury to the frozen outer reaches of Neptune, each planet could be seen as a snapshot of Earth's past or future. Imagine this. Every billion years the Sun ejects a massive ball of iron-rich plasma that eventually becomes a planet, starting with Mercury and ending with Neptune. Each stage of this planetary evolution could represent a different phase in Earth's history or future. So, if we follow this train of thought, what does it imply about the future of our own planet? As we journey through the cosmos, we see different stages of our own planet's potential evolution. The Uniplanetary evolution theory presents a fascinating perspective on this cosmic timeline, suggesting that all planets in our solar system represent different stages of Earth's evolution, visible simultaneously. Picture this. Every billion years, the Sun ejects a massive ball of iron-rich plasma that becomes a new planet. It begins as Mercury, composed mostly of iron and nickel. Gradually, it hardens, begins off-gassing, and develops an atmosphere of mostly carbon, heating up the planet and liquefying its core. Through volcanic activities and impacts, it expands into Venus. As the atmosphere acquires hydrogen and oxygen, water forms, cooling the planet and hardening its outer layer rapidly. This allows the development of an electromagnetic field, and thus a water planet is born. Life begins to accumulate from asteroid impacts, and the planet moves out of the Goldilocks zone, transforming into a hybrid rocky gas planet, Phaeton. Phaeton over time evolves into Jupiter, and then with the impact of a comet, Jupiter ignites, explodes and transforms into Saturn. As Saturn drifts further from the Sun and cools, its ring of debris dissolves back into the planet, giving birth to Uranus, which eventually becomes Neptune. While these theories may seem far-fetched, they challenge us to broaden our horizons and consider the infinite possibilities of our ever-evolving universe. But why does any of this matter, you might ask? The expanding Earth hypothesis isn't just a conjecture about our home planet. It's a challenge to our understanding of planetary evolution on a cosmic scale. It invites us to question our preconceived notions and rethink the evolution of our very own Earth. But its implications stretch far beyond our blue planet. If Earth has indeed been expanding, what does that say about other celestial bodies? Could similar processes be at play on planets beyond our solar system? This theory opens up new avenues for space exploration and the search for extraterrestrial life. It urges us to consider the possibility that planets we deem uninhabitable today might be at different stages of their own evolutionary journeys. In a universe filled with endless possibilities, the expanding Earth hypothesis invites us to question, explore, and wonder about the world beyond our own. Thank you for joining us on this extraordinary journey. If you are a passionate explorer of the mysteries in our cosmos and eager to uncover new perspectives, you've come to the right place. We post thought-provoking videos every day, so don't miss out on any of our mind-blowing episodes. Hit that subscribe button now and embark on more awe-inspiring voyages of discovery.